What to do when you hit a 404 error on Universe Today Space Tips. Oops. It seems like you've encountered a 404 error. The page you were trying to access has mysteriously vanished into the vastness of the internet. What went wrong? The specific page you were looking for could not be located. This could be due to several reasons. The link you clicked on may be outdated or incorrect. The page might have been relocated or removed entirely. There could have been a typo in the URL you entered. What are your options? Don't worry, there are several paths you can take to get back on track. Visit the homepage, https://www.universetoday.com, begin anew from our main site. Explore articles, https://www.universetoday.com/articles, discover our latest articles on space and astronomy. Reach out to us, https://www.universetoday.com/contact-us. If you think something is amiss, let us know. Feeling lost in space? Just like navigating the cosmos, it's easy to take a wrong turn sometimes. But fear not. There's a universe of information waiting for you at Universe Today. If you suspect this is a mistake, please don't hesitate to contact us, https://www.universetoday.com/contact-us, and share what you were searching for. We're here to help guide you back to the content you need. Space is immense. You simply cannot fathom how incredibly, astonishingly vast it is. Douglas Adams. Exploring the latest discoveries from the James Webb Space Telescope and NASA's DART mission. Imagine this, a telescope so powerful, it can spot a planet the size of Saturn over 111 light-years away. That's the James Webb Space Telescope for you, constantly shattering expectations. But here's where it gets controversial. This recent discovery of a Saturn-like planet, TWA-7b, around a young star wasn't caught using the usual methods. Instead, it took some clever trickery by blocking out the star's glare to reveal the faint planet. This not only opens up new ways to find exoplanets, but also gives us a unique peek into how planets might form. And speaking of space threats, what if our efforts to protect Earth from asteroids backfire? That's a concern after NASA's DART mission, which aimed to nudge an asteroid off course, ended up ejecting hundreds of boulders instead. These rocks didn't scatter randomly as expected but formed two distinct groups. This surprising outcome shows that space missions can have unintended consequences, making planetary protection more complex than we thought. Now, let's shift gears to something a bit more down-to-earth: coding. If you're new to programming or want to introduce someone else to this exciting field, check out Micro Adventure. It's an online game that teaches you the basics of coding through a fun, text-based RPG. You'll solve puzzles by writing code in a classic MS/DOS style emulator. It's a great way to learn coding concepts in a playful environment. Finally, for those interested in Morse code, there's Morse Code Defender, an Android app that turns learning Morse into a game. Imagine defending your ham shack by typing out Morse codes to shoot down incoming missiles. It's a fun and interactive way to master this timeless communication method. So why not ditch the endless scroll? James Webb captures the coldest exoplanet, 14 Herculis sees mysterious orbit revealed. Prepare to be astounded. The James Webb Space Telescope has accomplished yet another extraordinary feat, capturing the elusive exoplanet 14 Herculis c, a celestial mystery shrouded in darkness for over 2 decades. This monumental discovery is reshaping our understanding of the cosmos, revealing a world unlike any other in our expanding catalog of alien planets. Incredible discoveries, James Webb unveils 14 Herculis c, the coldest exoplanet ever captured. The James Webb Space Telescope has once again exceeded expectations by imaging 14 Herculis c, a frigid exoplanet located 60 light-years from Earth. Orbiting a star akin to our Sun, this exoplanet is the coldest ever directly observed, providing scientists with a unique opportunity to study a new class of planetary bodies. This groundbreaking discovery not only adds to our growing list of exoplanets, but also opens up new avenues for exploring distant worlds. unlocking the secrets of cold exoplanets. With its unparalleled sensitivity in the infrared spectrum, the James Webb Space Telescope has unlocked a new frontier in exoplanet research. William Balmer, a graduate student at Johns Hopkins University and co-first author of the study, states, "Webb's extreme sensitivity has opened up a totally new regime of study, enabling us to image colder exoplanets that were previously impossible to detect." The telescope's observations of 14 Herculis c have revealed a world distinct from those previously studied, broadening our understanding of the vast diversity among exoplanets. The 14 Herculis system, a fascinating case study. The central star, 14 Herculis, shares many similarities with our Sun in terms of age and temperature, albeit with a slightly smaller mass and cooler temperature. This system hosts two known planets, with 14 Herculis c taking center stage in Webb's latest observations. The telescope's capabilities allow astronomers to observe not just hot, young exoplanets but also older, colder ones, providing a more comprehensive view of planetary evolution and deepening our understanding of the formation and characteristics of exoplanets. Orbital anomalies and chaotic dynamics. The 14 Herculis system presents a captivating puzzle for astronomers due to its peculiar planetary orbits. Unlike the organized, flat plane of planets in our solar system, the two exoplanets around 14 Herculis exhibit an unusual and chaotic orbital pattern. Their paths intersect at an angle of approximately 40 degrees, resembling an X in space. This gravitational dance hints at a tumultuous history, possibly involving the expulsion of a third planet from the system. Such erratic orbits offer valuable insights into the early formation and evolution of planetary systems. William Balmer comments, "The early evolution of our own solar system was heavily influenced by the movement and gravitational pull of our gas giants." The gravitational interactions in the 14 Herculis system serve as a reminder of the chaotic forces that may have shaped our own cosmic neighborhood, prompting astronomers to ponder the impact of similar gravitational interactions on the development of our solar system. Investigating the atmosphere and orbit of 14 Herculis c. Webb's observations of 14 Herculis c have shed light on the planet's orbit and atmospheric composition. The planet follows a highly elliptical orbit, reaching distances of up to 1.4 billion miles from its host star. This positioning places 14 Herculis c between Saturn and Uranus in our solar system, offering a unique opportunity for comparative analysis. Through precise measurements of the planet's brightness at 4.4 microns, Webb has allowed astronomers to infer details about its atmosphere. Daniela C. Bartolez-Gagliuffi of Amherst College explains, by analyzing the brightness of a planet with a specific mass that formed 4 billion years ago and cooled over time without a source of energy to keep it warm, we can predict its current temperature. Interestingly, 14 Herculis c's brightness is fainter than anticipated, a phenomenon attributed to carbon disequilibrium chemistry. In this process, molecules formed at warmer temperatures in the lower atmosphere are rapidly transported to the colder upper layers, defying conventional expectations. This unique atmospheric characteristic provides a valuable comparison to the coldest brown dwarfs, furthering our understanding of planetary atmospheres. The future of exoplanet exploration. The discovery of 14 Herculis c represents a significant milestone in our exploration of distant worlds. As the coldest exoplanet ever directly imaged, it challenges our preconceptions and expands our knowledge of planetary diversity. The unusual orbital dynamics and atmospheric traits of 14 Herculis c provide a rare opportunity to study the forces shaping planetary systems and offer a glimpse into the possible fates of nascent planetary systems. As we continue to delve into the mysteries of this intriguing exoplanet, questions arise about the potential for other cold exoplanets waiting to be discovered. What other secrets do these distant worlds hold, and how might they reshape our understanding of planetary formation and evolution? The James Webb Space Telescope's ongoing exploration promises to unveil new frontiers and inspire further inquiry into the enigmatic nature of our universe.